Hello students, hope you have gone through the sequences and if there is any confusion, please email me. So today in this class, we are going to see that how we can visualize these number sequences. So that means that how we can represent them using any object or pictures or diagrams. So let's start today's class. All the sequences which we have done till now, they are represented in this chart using dots. So we are using dots here to represent those number sequences. If we see the first sequence, it has all ones and every one is represented using a green dot here. Okay, this is the sequence of all ones. Next, we have the counting number sequences, or it is also called natural number sequence. Here, every number is denoted by a red dot. So, in the first position, we have one dot because of 1. Here we have 2 represented by 2 dots, 3 by 3 dots, and so on. Next, we have the odd number sequences. So, as we learned, odd number sequence is the one which starts from 1 and then to get the next number, we will have to add 2 to the previous number. So 1 plus 2 is 3, 3 plus 2 is 5 and so on. Here these are represented using these blue dots. 1 with 1 dot, 3 with 3 dots, then 5 dots, 7 dots and so on. Similarly, we have next the even number sequences and the even number sequence starts with 2. The next number is obtained by adding 2 to the previous number. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8 and 8 plus 2 is 10. And here every number is denoted by a green dot. So at 2 for 2 we are using 2 green dots, 4 green dots and so on. Next we have the triangular numbers. So triangular numbers were the numbers where the first number is 1 and the next number is obtained by adding 1 to the position of the next number. So the position of this number is 2. So 2 plus 1 is 3. Then 3 plus 3 because the position of this number is 3. So this is 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. Then 15 plus 6 will be 21. This is called as a triangular number sequences and we are representing it using a red dot in a form of a triangle. For 1 we are using a single dot. For 3 it's a triangle using 3 dots. For 6 it's a triangle using 6 dots. For 10 it's a triangle using 10 dots and so on. Next we have a square. So here what is square? What is the sequence of squares? It is 1 square, 2 square, 3 square, 4 square, 5 square. So we can call it the square of the position or square of the natural numbers or integers here, right? Now here we are using a dot to represent the square numbers. 1 we are representing as a single dot, 4 using 4 blue dots, 9 using 9 dots and so on. So this is how we represent square. The next one is a cube sequence. So what is a cube sequence? Where it starts with 1 and it can be obtained by taking the cube of the position or the integer. So 1 cube, 2 cube, 3 cube, 4 cube, 5 cube and so on, right? And we are representing it in the form of a cubes as we can see here. So 1 is a single cube, 8 is a cluster of 8 cubes, 27 is a cluster of 27 cubes which is a cube itself, 64, 125 and so on. We can do it. Okay. Now this is exercise 1.3. I'm marking it as exercise 1.3 which is based upon these representation of the number sequences which we have just done now. So let us come to the exercise. The first question is copy the pictorial representation of the number sequence in the table 2 which is the above table and draw the next picture for each sequence. So as a part of this question, we have to draw the next picture of each sequence here. Let us do one thing. Let me solve this question here for you. Answer number 1 of exercise 1.3. So the very first one, it's a sequence of all ones. That means the next number will also be 1. So I can write a single dot and the number 1 here, right? Next we have counting numbers. So counting numbers means 1 dot, 3 dot, 2 dot, 3 dot, 4, 5. So next will be our 6 dots. 1, 2, 3, 4, 5, 6. And I'm writing 6 here. Okay. The next one we have is the odd numbers. Sorry. So this is 1, 3, 5, 7, 9. Next is 9 plus 2, which is 11. So I will draw 11 dots here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is 11. Okay. I hope this is clear. Next, we have even number. So even number is 2, 4, 6, 8, 10, and now 10 plus 2, 12. So let me represent using green only. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12, the next even number. Next we have the triangular numbers. So this is 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21. So next will be 21. Let me represent here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. So this is how we are going to represent 21 in a triangular number. So kids, see one thing here. These numbers, they are called triangular numbers because we can represent them in a form of an equilateral triangle. That means the triangle whose all the sides are equal. We know this already, that equilateral triangle is the triangle which has all the sides equal. Since we can represent them in the form of the equilateral triangle, they are also called as triangular numbers. Now let us count the number of dots on each side. Okay. So it is 1, 2, 3, 4, 5, 6. So on this side, 6 dots are here. Now coming to this side, 1, 2, 3, 4, 5, 6. Again 6 is there. And here also 1, 2, 3, 4, 5, 6. So each side has equal 6 dots, which makes it a equilateral triangle. Okay. Now, next we have a squares. So squares is 1 square, 2 square, 3 square, 4 square, 5 square. So next will be 6 square, and the 6 square is a 36 number. Now we have to make a 6 dot square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we have made a 36 dot square whose every side should be equal. So let us count again. 1, 2, 3, 4, 5, 6. It has 6 dots on this side. 1, 2, 3, 4, 5, 6. 6 here. 1, 2, 3, 4, 5, 6 here as well. And the last one on this side is 1, 2, 3, 4, 5, 6. So since all the sides are equal, it contains the equal number of dots. So that means we can represent it easily in the form of a square number. Next we have the cube numbers. Okay. So what are cube numbers? What is the sequence of cubes? This is 1 cube, 2 cube, 3 cube, 4 cube, 5 cube. And next will be 6 cube. 6 cube is 6 multiplied by 6 multiplied by 6. That comes out to be 216, 216. So now let's see how we have to represent it. But before that, we will see in this figure, we have only one cube. This is a cube of 2. So means we have 2 cubes here on this surface, and that multiplies to goes to 8. Similarly, 3 here, and that multiplies 3 times to give 27. 4 here, that multiply 3 times to give us 64. 5 here, which give us multiply to give us 125, right? So similarly, in the case of 6 cubes, we will have 6 cubes at the bottom and everywhere. So let us see how we have to draw it. So this is like this. Sorry, I'll just correct it. And this one. Now we have to make 6 cubes here. 6 means we have to make 5 separators. So 1, 2, 3, 4, 5. So that means we have 6 boxes. 1, 2, 3, 4, 5, 6, right? Similarly, horizontally also, we have to make 5 separators. 1, 2, 3, 4, and 5. Okay. So we can see this side 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Now, since it's a cube, we have to do same on every side of it. So this will be something like we have to extend this 1, 2, 3, 4, and 5. They should be equal. So when you're going to draw this with scale, it should come equal. 1, 2, 3, 4, and 5. So all sides we should have 6 equal cubes. Again, 1, 2, 3, 4, and 5. And here as well, it will be 1, 2, 3, 4, and 5. So kids, when you're going to draw this with scale, the cubes will be perfect. Okay, so this is how we have to make the cube of 6. So this completes our first question. Now let us move to the second question. Why are 1, 3, 6, 10, and 15, they are called as triangular numbers? So let us go to triangular series. This is the series of triangular numbers. So kids, since we can represent these numbers in the form of an equilateral triangle, that's why they are called as triangular numbers. Now what is equilateral triangle? Equilateral triangle we have already done in grade 5. It has all the 3 sides equal. So one we have 1 dot. If we will see this 3, so every side we have 2 dots. 1, 2 on this side, 1, 2 on this, and 2 here. Similarly, in 6, we have 3 dots here, 3 dots here, and 3 here. In the case of 10, 4 dots, 4 dots, 4 dots. And same with 15, 5 dots here, 5 dots here, and 5 dots here. So that means we can represent these numbers in the form of a equilateral triangle. That's why we call these numbers as triangular numbers. Okay, so I'm writing here answer number 2. Answer number 2 is we can represent 1, 3, 6, 10, and so on as equilateral triangle, that is all sides equal. The triangle has all sides equal. That's why we call them triangular numbers. Okay, so we call them triangular numbers. Now, next one is why 1, 4, 9, 6, 15, they are called square numbers, and why this series 1, 8, 27, 64 and 125, they are called cubes. So same we can see in the diagram. First let's see the square numbers. 1 is single. 4 we can represent in the form of a square having all sides equal. 9, again 3 dots on all side equal. Same with 16, 4 dots on each side, all the sides are equal. And same with 25, 5 dots on each side, so all the sides are equal. So we can represent 1, 4, 9, 16 and 25 as a perfect square. That's why we call these numbers as square numbers. So I'm writing here, I'm just making it a B part, square numbers. So we can represent 1, 4, 9, 16, so on as perfect squares, as perfect square. So we call them as square numbers. That's why we call them as square numbers. Okay. Now, the C part of this. C part is why we call these numbers as cubes. So, we just saw that we can represent them as a perfect cube. 1 cube, 2 cube, 3 cube, 4 cube, 5 cube and 6 cube. So, again here, we can represent 1, 8, 27, 64 as perfect cube. So we call them as cubes or cube sequence, cube numbers and all. Okay. Next, third question. Third question is, you will have noticed that 36 is both a triangular number and a square number. That's true. That is, 36 dots can be arranged perfectly both in a triangle and in a square. So now we have to make the pictures of 36 dot as a square and as a triangle. Okay. So I think for square we have already done here. See, in the case of square we have already done 36 squares. Now, in the case of triangular numbers, so first of all, let's see on which part it will fall. So, 15 plus 6 is 21, 21 plus 7 is 28, and 28 plus 8 is 36 numbers. So, it will come at the 8th position. Now, let me make a triangle of, I'm writing here, triangle with 36 dots. Okay. Yeah. So this is, I'm going to make it here. Till now we have done till 5, 15, yeah, till 5th position. So now I'm going to do for 8th position. So it will be something like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and 36. So we can see 1, 2, 3, 4, 5, 6, 7, 8 dots on this side, 1, 2, 3, 4, 5, 6, 7, 8 on this side, and 1, 2, 3, 4, 5, 6, 7, and 8, 8 dot on this side. All three sides have equal number of dots, so that's why we call it as a equilateral triangle also, and this number is a triangular number. Okay, so this is a triangle with 36 dots, and square we have already done above. I'm just writing square can be referred, square with 36 dots can be referred above. We have done it above, can be referred above. Now, the next part of this question says that this shows that the same number, like 36 we took in this example, can be represented differently and play different roles depending upon the context. So try representing some other numbers pictorially in different ways. So let me take some another number. I'm just making this as A part of this question, and B part is another number. Let me take 6. Let us try to make 6 with a even sequence. We can make a even sequence. 1, 2, 3, 4, 5, 6, right? So this can be represented as a even sequence. Also, we can represent 6 as a triangular number. 6 as a triangular number. Okay, I'm writing triangular number. So we can represent 6 in two ways. As the even sequence we have done, now triangular. So this is 1, 2, 3, 4, 5, 6. Okay. So this is a equilateral triangle with 3 dots on all the side, and total 6 dots we have. Hope this is clear. Now we will go to the next question. Okay. So next question is, what would you call the following sequence of numbers? Here the first number is 1 dot. In the second we have 1, 2, 3, 4, 5, 6, 7 dots. Then we have 19 dots, and then we have 37 dots. So what I am doing is I am solving this question here below. Okay. Answer 4. So if we look at the pattern of this particular sequence, we can see the first number is 1, and to the second number is 1 plus 6. We have added 6 here. Okay. And here we have added 12. So we can say this, because 12 plus 7 is 19, something 6 into 2, 12. And here we have added 18, means 6 into 3, 18. 19 plus 18 is 37. Okay. So what we can say here is that every number, the first number is 1 and the next number is the hexagonal multiple of the previous number. So this is 6, this one 1 plus 6 here, and then we are adding one more hexagon to it. So 6 into 2, 6 into 3. Now the next number will be 6 into 4. 6 into 4 is 24. So we have to add 24 to this number to get the next number, right? Which is 24 plus 37, which is equal to 61. Okay, I'm repeating this for you. The first number is 1. The next number is 6. We can call it as 6 into 1. The very next number is, we are adding 12 to 7. So we have done 7 plus 6 multiplied by 2, 12. And here 19 plus 6 multiplied by 3, we have done 18. And next we have done 37 plus 6 multiplied by 4. So these numbers, they are called as hexagonal numbers because we can represent them in the form of a hexagon. See, this is a hexagon. A hexagon has 6 sides. So 1, 2, 3, 4, 5, 6. We have 6 dots. Okay. And then this is this hexagon, and on top of that another hexagon is there, which is a big hexagon, and it has 12 more dots. And in the next one, after these two, we have 18 dots. That is the 3 times bigger hexagon we have. So now in the next one, we'll have 4 times bigger. So how we have to represent it? Let us see. I'll make it here. Wait. Or I'll do one thing, I'll just make it here. So if you can see, this one has 1 dot, this has 3, this has 5, this one has 7 dots. So next we'll have 9 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then it has 1, 2, 3, 4, 5, 6. So decreasing order we have to make. It was 9. Now I'm making 8. 1, 2, 3, 4, 5, 6, 7, 8, followed by 7. 1, 2, 3, 4, 5, 6, and 7. Then followed by 6. 1, 2, 3, 4, 5, 6, and then 5. 1, 2, 3, 4, 5. See, in this one, it was your 3 and then 1 layer. When 5 was there was 2 layers. When 7 was there was 3 layers. When 9 is there, we have 4 layers above, and similarly 4 layers below. So 1, 2, 3. Same thing we are going to repeat in the form of a hexagon. 8, then 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. This. So if you count it, these are 61 dots. Okay, and it is in a form of a hexagon. This is in a form of a hexagon. Okay, so these numbers, they are called as hexagonal numbers, where the first number is 1 and the next number is a multiple of 6. So we are adding one hexagon in every sequence. Okay, next I'm just writing the series here, and the diagram you can see from here. Okay, I'm just writing it as 1, 7, 19, 37, and then 61. They are called as hexagonal numbers. Hexagonal numbers, and can be represented. They can be represented in the form of a hexagon. Okay. Now, the next one is last question of this exercise, and I am dividing this in two parts again. The first part is, can you think of pictorial way to visualize the sequence of powers of 2? So first one, we will make powers of 2. What are the powers of 2? 2 raised to the power 1, 2 raised to the power 0, that is 1, 2 raised to the power 1, which is 2, then 2 raised to the power 2 is 4, 2 raised to the power 3 is 8, 4 is 16, and so on. Now, if we have to represent it, then we can do it this way. First we have 1, so it's a single number. Then 2, something like this. Then we have 4. So 4 is 1, 2, 3, and 4. We can represent this in a form of a square. Then we have 8. 1, 2, 3, 4. This one. And again 1, 2, 3, 4. So this is 8. Okay, and we can join these. This here. Wait. Okay, I'm drawing it again. Sorry. This is 1, 2, 3, 4. Next is 1, 2, 3, 4. And bottom to bottom and sidewise and top. Okay, so this is 8. Now this one is 8. This is 4, 2, 1. Now if I have to make a 16, I'll make this picture 2 times and I will join it. Okay, so I can write here 1, 2, 3, 4. This one, sorry, wait. Yeah, this, top and bottoms, and then one more to it, squares, and then we can join these as well. Okay, we can join these also. So this is how we can extend. Now if I have to make 32, it will be extension. We have to do this once and this one time more. So this is how we can make a power of 2. Okay, next one is power of 3. So power of 3 is, we have the series 3 raised to the power 0 is 1, then 3, then 9, 3 raised to power 2, 3 raised to the power 3 is 27. Then after 27 we have 3 raised to the power 3 is this, 3 raised to the power 4 is 81, and so on. Now if we have to represent it, we can do it something like this. For 1 we have single dots. For 3 we can make a triangle. For 9 we can make one triangle and another triangle and one more triangle. Or let me do it this way. We can make like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, in a triangular form. This is for 9. So now if I have to make 27, I will repeat this structure 3 times. Something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, which make 27. And if I have to extend this further, this one, then I will add one more structure to it and it goes on. Okay, so this is 27. So likewise, we can make the structure for power for 3. So kids, what we have done today, we have done exercise 1.3, and first of all, we have learned the pictorial representation of the number sequences. Then we learned why these are called triangular numbers, because they can be represented in the form of an equilateral triangle. These numbers can be represented in the form of a perfect square, all sides equal, and these numbers as we can represent as perfect cubes, again all sides equal. Okay, in the form of a cubic structure. Then we have learned that how we can represent one number into different forms, like we took 36 and we have drawn 36 as a square in the above sequence. Here we have done it as a square, and also we have represented 36 as a triangle here. Okay, and the next question we have seen a new structure which is called as the hexagonal numbers, and they are called hexagonal numbers because we can represent them in the form of a proper hexagon. and every number has one more hexagon added to it with the multiple of the position of that number, right? Next is how we have to represent the power of 2. So power of 2, we can represent it in the form of a square and then we can join. And if we have to draw the large structures, we can repeat these structures. Then we have power of 3. Power of 3 we have drawn as triangles. And again, as the number gets large, we have to repeat these structures. I hope this is clear to you and I really want you to go through it. Try to draw all these structures on your own. And if you have any queries, you can always email me. So this brings us to the end of this class and I will see you in the next class.